Hello, math analyzers. Welcome to another day talking about your unit circle in Chapter 9, Lesson 3. So I am going to start filling in the unit circle again so we can go back through exactly what we did when we just filled in the unit circle in the previous day. All right, so here we are. Let's fill in the unit circle. We'll, of course, start right here with the 0, 0, right? 0 degrees and 0 radians, which also ends up, because we come full circle, as 360 degrees and 2 pi radians. That particular point, since a unit circle is from 0, 0 out 1 unit, is at 1, 0. Okay, we'll do the easy ones, right? Then up here is 0, 1 on the y-axis. That's 90 degrees, and that would be pi over 2 radians. Back over this side, negative 1, 0, 180 degrees, and pi number of radians. So a half circle is a total of pi radians. This is the halfway, so 1/2 of pi, half pi, right? Then down here, we're down to 0, negative 1 on the y-axis, and this is 270 degrees. 3 pi over 2 is our radian measure. And then that puts us back up at the 2 pi, 360, 1, 0. So we'll break down quadrant 1, of course, where everything is positive. And when we're at 30 degrees as our reference angle, this is the same as pi over 6 radian measures. Okay. This, if you kind of look at it, you can even eyeball this. When it comes to the 30, 60, 90 right triangles, if I were to drop an altitude, create a right angle here, and look at this in proportion, my x and y's, right? Where are they? The x is the distance from here to here. That's the x coordinate. And the y is the distance from here to here, how far up we've gone on the y-axis, right? And we've gone halfway up the y-axis because of the proportionality of the 30-degree angle. 1, radical 3, 2. So 1 over 2 is this value right here. And the x value from here to here is radical 3 over 2. We're going to put that together a little bit today. A little bit more info on that. But since I mentioned the 60 is just the opposite, it's pi over 3 radians. 60 degrees, pi over 3, 30 degrees, pi over 6. See that little like switcheroo there? Now this guy is just the opposite two values. 1/2 is its x value. Radical 3 over 2 is its y value. Last one in here for quadrant 1 for the reference angle is the 45, 45, 90, right? And if you do the 45, 45, 90, then the two sides are equal, which is why the two coordinates are equal. And since they're 1, 1, radical 2, but you can't leave radical 2 in a denominator, we've rationalized it to be radical 2 over 2 for both the x and the y coordinates. And once you know quadrant 1, you can really do everything else around for quadrant 2, where it's negative and positive. Quadrant 3, where it's all negative. And quadrant 4, where it's positive and negative. So let me actually just do the coordinates all the way around, because it just goes back with your reference angles, right? So let's just do the coordinates all the way around. 30-degree reference angle match up right here. 30-degree reference angle right here to here, 30 degrees. So this would be negative radical 3 over 2 and positive 1/2. 45-degree reference angle, it's negative radical 2 over 2, but still positive radical 2 over 2 for the y. 60-degree reference angle, right? Here's the reference angle. So this is the 60-degree reference. It's just the opposite. It's negative 1/2, positive radical 3 over 2. So notice those just switched to have negative values in all the x coordinates. Down here, everyone is negative. Both x and y are negative coordinates. So this would be your 30-degree reference angle is negative radical 3 over 2, negative 1/2. Your 45-degree reference angle, both negative radical 2 over 2's. And your 60-degree reference angle, because remember, consider here to here is your 60-degree reference angle, that's negative 1/2, negative radical 3 over 2. And the last one, think of your reference angles. This is your 30-degree reference angle. So now your x's are positive again, but your y's are negative. So positive radical 3 over 2, negative 1/2. Here's your 45-degree reference angle, positive x value for radical 2 over 2, negative y value for negative radical 2 over 2. And then here's your 60-degree, positive x value, 1/2, negative y value, negative radical 3 over 2. Now I'm just going to do all the degree measures around to match it back up. And I just realized, looking straight ahead, that I forgot to write down your radian measure for 45 degrees, right? I think of it this way, 4 pi over 4. And that makes sense because it's half of pi over 2. It's pi over 4. So all your 45-degree reference angles are all add 45 degrees to the right angle prior or subtract 45 degrees from the right angle prior, right? So add 45 to 90, you get 135. Then add 45 to 180, you get the 225. Add 45 to 270 or subtract 45 from 360, you get this 315. Okay. Let me do the matching radians for the 45s. They're all over 4, and they're all those odds, those odd numbers over 4, right? So this was 1 pi over 4. This is 3 pi over 4. 4 pi over 4 is technically 1 pi, right? So then this is 5 pi over 4. 6 pi over 4 reduces to 3 pi over 2. So that's where you get this one from, right? We're doing fourths all the way around. And then up here, you get 7 pi over 4. 5 pi over 4 was over here. You get 7 pi over 4 because 8 pi over 4 is the same as 2 pi. So that's what this is that gets you back up here. So notice these are a little bit more than 1 because we got 1 full rotation to here, 1 full radian, and then we continue those radians to get 2 pi total. So now if I do the 30s and the 60s, think of it as having the 6th as the denominator is actually what you have here as well. It just reduced to a 3, right? So this really has a 6 at the bottom, right? That really had a 6 at the bottom. So if I multiply up here by 2, it was 2 pi over 6. That's what reduced to 1/3. So you can really think of all these that way, okay? So if we come over here, let's see, this guy was 2 pi over 6 that reduced to 1/3. This is 4 pi over 6 that reduced to 1/3, or 2/3. So 2 pi over 3, and we just add 60. Sorry, we add 30 here because we did a 30-degree turn. So that's at your 120. Okay, these guys, when they have the 60-degree reference angle, they have the denominator of 3. Then this is a 30-degree reference angle. So you can either add another 30 here, or you can subtract 30 from 180 to get yourself to the 150. And then this is something pi over 6, right? Well, let's think of how close we are to 6 pi over 6 that reduces to 1. We're just 1/6 away from that. So that would be 5/6, 5 pi over 6. Now we're going to be one above that, right? So this is the 6 pi over 6. Now this guy is 7 pi over 6. See that? And then add 30, you get 210. If you add another 15, that's where you get to this 225 and your 45-degree reference angle, right? So then if we add 30 to this guy, that's where you get the 240. And if you think about it this way, well, this is going to have to reduce. This is a 6 that reduces to having a 3 denominator, right? So let's think of how many thirds we've had going. This was 3/3 or 1. So now we have one more third going here. That's 4 pi over 3, just above, right? Just each of these is just above its denominator. Each of these is just above its denominator. Then you get down here to that 270, add another 30 for this side. That's where you get this 300. Now that's a 60-degree reference angle if you're coming from here over. So that means for radians, this is going to reduce to a third, right? And that, since 6 pi over 3 reduces to 2 pi, then 5 pi over 3 is the radian equivalent. We, of course, add 15 there, then add another 15 to get you to 330, which is your 30-degree reference angle away from 360, right? So this guy has a sixth as its denominator. We're almost to 2 pi, right? We're almost to 2 pi. We're almost at 12 pi over 6. We're just 1/6 away from it. 11 pi over 6 is what we get to. That's filling in the whole unit circle, okay? Definitely recommend pausing it and looking at that and really analyzing. It's not that much. It's a lot that comes together in your quadrants, and it's that information over years that we've built that puts us here and able to fill all this stuff in. So what I'm going to talk about today is really what the coordinates mean that then pulls trigonometry into this circle. Okay, literally into the circle. And it has to do with what I was talking about when it comes to the 30, 60, 90 right triangles and the 45, 45, 90 right triangles. Okay, so if I just look right here, okay, at this right triangle right here, this 30-degree reference right triangle, go from here to here, and I pull my altitude down right here. And I know that this is a 30, 60, 90 right triangle that I just put in the pink. Okay, so I just outlined that guy right here. And I know from here to here is 30 degrees. Okay, since this is 90 degrees because I made the right angle with the x-axis right here, then I also know that this angle measure up here is 60 degrees. And I know that the proportions of my sides are in 1, radical 3, and 2 as their proportions. But I also know that this radius right here is really just a 1, right? So since this entire radius is 1, I take half of that to get this distance right here. And I take half of that, right? I took half of 2 to get this to be a 1. So I just reduced those down. And then look at the coordinates that match. This is your x. Look at what your x is. This is your y. This is what your y is. Now I'm going to tape that even further. Okay, so this coordinate matches exactly where we are right here on the x-axis. That's what coordinates mean. And it matches exactly where we are right here on the y-axis. Okay, so far so good. Now I'm really going to blow your mind. Let's do the sine of 30 degrees in our graphing calculator. So over here, I just want to make sure that my mode is degree mode, and then second and mode gets me back out. Let's do the sine of 30 and see what we get. Okay, because I want you to think about this. Sine is opposite over hypotenuse. 1/2 divided by 1, it's 1/2. Let's do the cosine of 30 real quick. So cosine 30 and plug in. Oh, some irrational thing. Wait a minute. That decimal looks really familiar. Back in chapter 8, when we first did the sine ratio and the cosine ratio, I had you plug in a bunch of stuff. Hold on. Radical 3 over 2. Because it's adjacent over hypotenuse. And this divided by 1 is still this. What are your coordinate points values? They're your values of sine and cosine for your angle. That's where they come from. That means your coordinate point is actually the sine of your angle. Oh, excuse me, I did it backwards. Cosine is x, sine is y. The cosine of your angle measure and the sine of your angle measure. That's where this coordinate point comes from. That's the connection to trigonometry. So the way that we look at this, the way that we think about the unit circle's relation to trigonometry is in mini triangles that we draw their altitudes throughout the unit circle. Okay, I could do that again with 45. I could do that again with 60, but that's where all these coordinates start to come from. These coordinates are all going to be cosine of theta, your angle measure, and sine of theta, your angle measure. Okay, that's what those are going to be. So this is really cool when it starts to really come together like that and make a little bit more sense. That's where these functions of sine and cosine are really coming from. So notice I did that right here. I took out my special right triangles, right? What color did I do for the 30? So I did this like darker. Okay, so I'll do this again. And again, because it's 30, it's 1 radical 3, 2, but we have to divide everything by 2. So this is 1/2, and this is radical 3 over 2, right? And then we do that for 45. Okay, so from here to here. And again, this is 1 radical 2. So we divide both of these things by radical 2, which gets rationalized to radical 2 over 2 for both lengths. And then you do that again right here. Oh, it's stupid purple. And it's the opposite of what we did with 30. So this side is your radical 3 over 2, and this side is your 1/2. Because again, we're dividing by 2. That is what led us here. That's what leads us to what exactly that X and Y are standing for. And when you put all that together, man, it's really cool what we are going to be capable of doing because we've connected our work with the proportions of the sides in the right triangles to these special right triangle angles, to putting it into a circle, to radian measure, to actually looking at quadrant signs again. I mean, all of it is just really coming together well. And we're going to be able to do a lot with it as a result. But you really want to make sure you know this unit circle. So here's one completely filled in for you. Okay, so here's one right at the end. It's obviously off to the side and I flipped it over so you can look at it. But keep looking at these and keep getting some of these values down so you can understand when I take and unravel this. I'm literally going to unravel this for you. It's so fantastic how much of this comes together because it's a payoff for all the work you've been doing in your different math classes over the years. All right, just going to add this guy at the end. So it's one more person showing you how to fill in this unit circle and how you don't have to memorize it. And it's another perspective. I was told to memorize this when I was in school. I'm telling you, you really don't have to. You can do the figures that get you all the way around this. Okay? All right, enjoy Mr. Bourne over here and his cat. I love his cat because it's black. I'll see you guys soon.
Hi, everybody. This is Mr. Bourne from Minnesota and his trusty cat. And this tutorial will be on the unit circle, radians, angles, and points. Now, if you want to learn this fast, this is the tutorial to watch. What you will learn: what the unit circle is, how degrees and radians relate, finding radian measure, and finding the XY exact coordinates of important radian measures, all under 8 minutes. First, let's talk about what a unit circle is. What you're seeing is an XY coordinate grid. This is a plane with pairs of coordinates, and a unit circle is centered at the origin. There it is, little unit circle with a radius of 1. Let's zoom in to get a little bit of a closer look at it here. Okay, there we go. Now, radius of 1 means that I can lift out this little blue piece here, and this is the radius. And as you can see, no matter where I hold it, it's got a radius of 1 exactly. Now, if we take that radius and we curve it, here's a curved piece. It's the same thing, it's curved and I've colored it purple. If we take this curved piece and we get a few more, 1, 2, 3 more of them, these will fit exactly in the circumference of the circle. But in just a second you'll see, hang on. That there is just a tiny little piece left over. So the radius will fit around the top hemisphere of the circle 3 times plus a little bit extra. And this little bit extra, which is right here, is 0.14 long. So it takes 3.14 radiuses or radians to fit around the top half of the circle. Okay, so let's move that little 0.14 piece in there. Okay, 3.14, that is pi. So around the very top half of the circle is pi radians, and the bottom half of the circle is another pi radians. So the complete circumference around a unit circle is 2 pi radians. This should be familiar. If we go to the formula for the circumference of a circle, it's circumference equals 2 pi r. Well, since we've got a radius of 1, that makes the math simple, right? There you go. So now you know how the formula got to be that way. Okay, now I'm going to tell you how radians and degrees relate. Okay, what you're seeing here is a slightly different picture of the unit circle, and the red side, which is moving around, is going to be called the terminal side, and the green side is going to be called the initial side. So I put it in your heads that a radian is a length, and I'm going to adjust this so that, there we go, the terminal side is 1 radian away from the initial side. So this is a length along the outer edge of the circle here. But a radian can also be describing the angle formed by the terminal side and the initial side right inside here. Okay, well, let's bring degrees into this. So there we go. We see this is 57 degrees, and that is the same thing as 1 radian. Alright, well, it might not seem very natural and they don't quite go together, but let's just move this around here and we'll see where the logical matchups are. Right here, at exactly halfway point on the way to 1 complete pi radian, this is pi over 2 radians, and that's 90 degrees. And over here we've got 1/4 pi, or just pi over 4, is the same as 45 degrees. And over here we've got 3/4 pi is 135 degrees. And of course here is 1 complete pi, and that's 180 degrees. But there's a few other important ones. There is 30 degrees, which is 1/6 pi. 60 degrees, which is 1/3 pi. 120 degrees, and although the radians didn't make it look nice, this is actually 2/3 pi, or 4/6 pi. And over here, 150 degrees, which is 5/6 pi. Okay, let's move on. Let's talk about how to convert degrees into radians. The formula for converting degrees to radians is degrees divided by 180 times pi. So I'm going to move this randomly here and just kind of put it there. And we see we've got 72.06 degrees. Alright, let's bring in a calculator and try to convert that. 72.06 divided by 180 and multiply that by pi. 1.2576, and that is the angle in radians. Okay, so let's convert between given radians to get a degree measure. Here's the formula for doing that. You take your radians, divide it by pi, and then multiply by 180. Here is the calculation for that. I encourage you to give this a try on your calculator. Just put in 3/4 times pi divided by pi times 180, and there we go, 135 degrees. Okay, we're on to the last part. This is the complete unit circle, and I'm going to show you how you can find the various points of interest, the XY coordinates of places along the edge of the unit circle. What you're looking at is the upper right quarter of the unit circle. Take a look here at the coordinates for 30 degrees or pi over 6. The x coordinate is square root 3 over 2, and the y coordinate is 1/2. So think of this as being part of a triangle, with the vertical leg on the bottom being square root 3 over 2 long on the x-axis and being 1/2 high on the y-axis. And naturally the hypotenuse is 1 unit long. Now here's where sine and cosine come into play. If you take the sine of pi over 6, you will get 1/2. And if you take the cosine of pi over 6, you will get square root 3 over 2. Now when you do this in your calculator, you'll get a long decimal. But you can confirm that this is square root 3 over 2 by typing it in and taking a look. A final word on some strategies for helping you to memorize some of these XY coordinates along the outer edge. Look for symmetry. Look and see how similar and different the 30 degree and 60 degree mark are. Notice that all the starting x coordinates for everything on the left side of the y-axis is negative. And keep in mind, the only numbers that you have to memorize are 1/2, square root of 3 over 2, square root of 2 over 2. Alright, well hey, thanks for watching this video. Hit the like button if this was helpful, and share it with your friends and your teacher. Alright, bye.